Hello everybody, welcome to our lesson. Today's topic is problem solving on the topic electric generator. This is the goal of the lesson. At the end of the lesson, you'll be able to use the equation for the EMF of an electric generator. And as always, before we start solving problems, it will be useful to recall the equation for the EMF of a generator. So, generator, we said it's a rotating coil, and the EMF produced depends on the number of coils and the magnetic field, the area of the coil, and how fast it rotates, its angular frequency we call, and to the orientation, sign WT. Now let's move to the problems. Well, this is the first problem. First of all, let's read carefully and write down the information from the text. Okay, what we got? We know that the number of turns is 8 and the area of a loop is 0.09 meters squared, and the total resistance of the wire is 12 ohms. And the coil rotates in a 0.5 Tesla field. So we know the field, the strength of the field. And also we know the rate of the rotation, as we call the frequency. It is 60 Hertz. Now, what we're asked to find? In A part, we're asked to find the maximum EMF. And at the B part, we're asked to find the maximum current. Well, now let's move to the solution. What we have. So, this is the equation for the maximum EMF. In other words, we can call the peak EMF. So, all the information is given except angular frequency. Angular frequency can be found by this equation, and let's calculate here. So the answer is 120 multiplies to 314. It is 376.8. 376.8. The unit for the angular frequency is radian per second. Now, we know all the information is here, so we can find the maximum EMF. So number of turns it is 8, field it is 0.5, area it is 0.09, and angular frequency. So let's calculate 4 to 0.09, 376.8. So we need here a calculator. So let's calculate. The answer is 135.65 volts approximately. Now we've found the maximum EMF. Then what is the maximum current? So from the Ohm's law, it is EMF over resistance. So over 12, and the answer is 11.3 amperes. So we found the maximum EMF and the maximum current. So that was an easy question. Now let's move to the second problem. Okay. So if you read the text, the number of turns is 200 and it is a square coil, so the side of the square coil is 0.04 meters and it is located and rotated in a uniform magnetic field of 1.5 Tesla. And we also know the peak EMF, the maximum EMF, it is 12 volt. And how fast do you need to rotate? So we need to find the frequency. Well, frequency shows how fast the coil rotates to generate a maximum EMF of 12 volts. So let's use the equation you already know, NBA W, and the angular frequency it is 2 pi f. So we can substitute into the equation. So it will be NBA 2 pi f, and here f is equals to over NBA times 2 pi. So if we put the numbers, what we get? 12 volts, and it is 200, and the field it is 1.5 Tesla. The area, we don't know the area. We can find the area here. We said it is square, so we just multiply two sides. 0.04 squared, 0.0016 meters squared. This is the area of a coil. 0.0016 times 2 pi, it is 314. Now, frequency is equals to 12. Let's calculate 200 multiplied to 1.5 multiplied to 0.016, and the answer here will be 301.44, and the frequency is 398 Hertz. Approximately we can say the frequency is 4 Hertz. So what does mean 4 Hertz? In 1 second this loop rotates 4 times. Get it? So 4 rotations in 1 second. That is the speed of the rotation of a coil. Now let's move to the third problem, and it is the last problem. Okay, again let's write the given here. What we have, we know that the coil rotates from 0 degree to 90 degree, so it's 1/4 of a revolution, and at an interval of time it performs this motion at 15 microseconds. Sorry, this is milliseconds. So we know the number of turns, it is 200, and the circular coil has a radius of 0.05 meters, and it is located in a uniform field of 1.25 Tesla. That's it. We are asked to find at A part the maximum EMF, and at the B part the average EMF. Well, I hope you know the difference between maximum voltage and average voltage. So I'll start just by solving with the equation you know. And how can we find W here? So we can use this equation actually, but it is inconvenient because we don't know frequency. Actually we can find frequency, but it will be easier to use this equation instead. So we know the angular speed, it is angle divided by change in time, change in angle divided by change in time. So the angle changes from 0 to 90, so the change in angle is pi over 2, and the time is 1510 minus 3. So here pi must be in radians because the unit for the angular speed is radians per second. So that's why 314 over 2 divided by 1510 minus 3. So angular speed is 1.58. This is half of pi over 1510 minus 3. So approximately angular speed is 105 radians per second. Now we can just put into the equation for the EMF, the maximum EMF. So N, it is 200, well, B, it is 1.25, area, well, also we don't know the area, but we can find it. We know that this is circle, so that's why PR squared, 314, 0.05, this is radius. So answer would be for the area 0.075, 0.0785 meters squared. So this is the area, and okay, let's put it into the equation. What we get here, 0.075 multiplied to angular speed, this is 105. So all we need is just to calculate this. You can use a calculator. Now the answer approximately, the answer is 206.1 volt. We can make an approximation up to 206 volts. We can say the maximum voltage is 206. Now the B part, how can we find the average? So note this, to find maximum we've used this equation, but to find an average we need an interval of time. So basically we can use the Faraday's law of induction to find average induced EMF. So here we need to find change in flux. So change in flux is final flux minus initial flux. So here flux is changed because of the orientation, because of the angle. It means that multiplication of BA is constant, it doesn't change. So the final is when the 90 degree we have minus cosine 0. Final it is 90 degree, initial state it is when the angle is 0 degree. So change in flux is equals to BA, cosine 90 it is 0, cosine 1 it is 1. So we have minus BA. Now let's put the numbers. 1.25 Tesla. The area is 0.0785. So the change in flux is equals to 0.098125 Webers. And now what we do, sorry, with the minus sign, change in flux is negative here. So average can be found by minus 200, here is minus 0.098125 over change in time, interval of time, it is 1510 minus 3. So again, if you use a calculator here, you can find the answer. and the answer is approximately 131 volts. So, sorry, this is average. Average voltage is 131 volt. So we see here with the maximum EMF is bigger than the average EMF. So that looks right. Well, that's the end of the lesson. I hope you've enjoyed solving problems with us. If you like our video, please subscribe and share. Thank you.